Okay, so today we'll be starting with the streaming part. Okay, so there are two different modules on Spark for the streaming part. One is called Spark streaming and another is called structured streaming. And we will be discussing the structured streaming part because Spark streaming is the legacy one now. And so we'll be discussing about the structured streaming part. So let's first quickly download the code. So we have this streaming PY master. Okay, so this is the code and yeah. So basically what we can do, can we download the code directly there? I think so. So you're not stopping the cluster, is it? Yes, sir.
Yes, Siddharth.
So it'll be charged like lot, right? You know. Can you just leave the control?
Yes.
Let me quickly do the setup and then I'll come to you on the discussions part. Okay. And what about the then I need the secrets file also. I'm copying it, right? Okay. Okay, now my dot secrets files is also appearing here. I'm not sure it's appearing or not. No, it didn't come, right? Okay, it's there, but it's not appearing. Okay, fine. So let's first discuss like some theory part of like streaming. So the objective here is basically, so till now, whatever the applications we have executed, these are all batch-based applications, isn't it? So you are creating an application which is running in a batch mode. Batch mode means your data is basically getting accumulated on your data is getting accumulated on the source side, and then you are processing it at a regular interval. Okay, your data is basically accumulated in databases or some cloud storages or some shared directories and all, and you are processing it at a regular interval. Say you are processing at a daily level, or you are reading or processing it at a weekly level, like that. But apart from those batch use cases, there are some real-time use cases also there. Real-time use cases means data is generated on a real time, and you have to process it instantaneously. Okay, there are many such use cases where you will be required to do this kind of real-time processing. And examples are numerous examples. I'll give you 3 to 4 examples which I have worked till now, but you can again further self-explore for more and more examples. First one is basically if you have heard about real-time recommendation systems, like when you will be working closely with the data science team, if you get a chance to work in a data analytics company, so you will get a chance to work with the data science team. Okay, you'll be working with a data science team, and and data science team is creating some real-time recommendation system or basically time series forecasting system. These are different machine learning use cases. So you will be working closely with them to make these applications work in a real time. Okay, so a person is coming real time to a e-commerce company, so you have to show him or her the recommended products. Okay, so that like you can sell more and more products on your system. So those kind of applications are real-time recommendation system. You can introduce streaming part there. Fraud detection systems, like transactions are happening on the real-time basis. Like take the example of any Indian startups, like successful startups like Paytm, PayU, Razorpay, these companies. Transactions are happening at every second, every millisecond. So there can be fraud transaction happen on your system. So you have to build a system that will detect fraudulent transactions on a real time. Okay, you are swiping or you are basically uh, sending some money or basically swiping your card in a Razorpay gateway. So your transaction is going through their gateway. So you have to basically make sure. So Razorpay has to make sure like these transactions are happening. These are legitimate transactions. It's not like somebody else got hold of another person's card and he is trying to misutilize that, right? You have to basically build a system that will detect if a system is if a transaction is a fraudulent transaction or not. So those kind of systems also you can build using structured streaming. Okay, so these are kind of the systems we have, and similarly, so this is basically real-time machine learning, real-time processing, that is for fraud detection system. And nowadays, a couple of other things are also coming. Real-time dashboards. Many companies are creating real-time dashboards, also real-time reports. Okay, so all these IoT companies and all. So the stuffs or the business is happening on a real-time basis, and you have to create a dashboard which is refreshed every second or every few seconds. Those kind of dashboards also you can build, rather the backend data you can build. Maybe you can create a streaming application that publishes data to Elasticsearch. Elasticsearch is a high performance, means fast searchable data storage. So you are building an application which is dumping data to those kind of system, and some real-time dashboards like Kibana software has been used to create different dashboards which is getting refreshed on the real time. Those kind of applications also you'll see like you may get a chance to work on that. And another type of use cases are basically CDC, change data capture. So in the production databases, some transactions are happening, and you have to basically capture those changes instantaneously and basically update your warehouse. Okay, basically you are creating a warehouse which is very real time. Okay, so that can be used for many different use cases. Okay, your business analysts are querying your data. You have created some reports which is getting refreshed at a regular interval. So those kind of backend data you can prepare using streaming applications. So these are the major type of four, 5 use cases. You may get a chance to work on that. Sometimes you may read data from some browser cookies, okay, for different e-commerce companies, and user activity data, how different users are coming to your website, what are the landing pages, okay, how the navigation pattern in each product, how much time that person is spending, what's the search criteria. All these things people are searching for, and you have to basically capture those search events, process it to make some insight, to get some insight out of it. So those kind of applications you can work. Those kind of applications you can work on on this streaming use cases. Okay, so structure streaming is used for those kind of use cases. Okay, that is there. And now next thing is basically okay, so we'll be executing those kind of examples here using structure streaming. Okay, structure streaming is basically is used to read data from some streaming sources and processing it and storing it to some databases, some warehouses, or some file systems, or you're sending this email, just like fraud detection system. If you detected a transaction is a fraudulent transaction, you immediately send a email to your support team, isn't it? Those kind of applications also you can work. So you'll see some Lambda architecture. Lambda architecture is nothing but the source is same, but sinks are two different type of sinks. So the same e-commerce browser cookie retrieval, what we discussed, you can read the data and you can make some real-time decisions. And the same data you can store it for further batch processing or reporting. Okay, a person is coming to our website. He's searching for some mobile under 20,000 budget. You have your real-time recommendation system is there, which is reading that particular data and on the fly it's making some business decision like what are the best similar products you can basically once again. So what are the best products you can recommend them, so that maybe the chances of conversion will become high. That is one use case, and the same data can be stored in the batch layer, like in HDFS or S3, so that at a regular interval, at a daily basis, you just read those data, flatten it, give it a good format, then write it to say Cassandra or say DynamoDB, so that your business analyst can basically get different insights from those kind of data, isn't it? So these are the different kind of use cases you can work on this. These are the different kind of use cases what you can work on this. Okay. So that is there, and these are the different type of use cases. And post that what? Yeah. So these are the different type of use cases. Now we will see a couple of examples here. So what are the type of examples we'll be seeing? We'll be seeing how to read data from different streaming sources. We'll see two such sources. One is just a file system from S3 bucket. Files will be getting added very frequently, and we'll be reading and processing it. That is one type of use case we'll see. Another type of use case we'll see, like we'll set up a Kafka cluster. We'll set up a one node Kafka cluster and we'll start processing data from there. So these are the two different type of use cases we'll be seeing. Okay, so we just downloaded the code. I need 2 minutes. First type of use cases what we'll be trying is basically we'll be reading data from S3 bucket. Okay, so just imagine like there are some systems which are continuously dumping data into a S3 bucket. Okay, so at a very high speed, say every second, hundreds of files are getting added to that bucket, and we have to process it instantaneously. Okay, that's the whole idea of the first use case. Let me quickly open it. Can you import the project that what we just imported, downloaded now? Sure. Okay, file, open. New window. So here basically what we'll be doing, we will be basically reading data from S3 bucket and we'll be processing it instantaneously. So for the processing front, there are two different modes of processing. One is append mode, another is complete mode. Okay, append mode is basically when the data is coming continuously. So you have to process only the new data at a regular interval. Every 5 seconds, whatever the new data has arrived to your system, you want to process those data. Okay, every time new files are getting are arriving to your system, so we are processing them in every 2 seconds or every 5 seconds, or basically you are saying whatever the number of files getting added, just process 5 files at a time. Okay, every second some 2, 3, 4, 5, 10 files are getting added. So I have mentioned like process 2 files at a time. So in that way, it will keep on processing that. Okay, so append mode. So let's see like what we are trying to do. So coding wise, you will not see much difference. Okay, because in the latest streaming framework, they have just unified the syntax. Okay, just like the same syntax you were using for data frame, similar syntax you'll be using here also. Okay, so first you read the configurations and all this. This is the location from which you will be reading data path. Okay, so where it is coming from? Application by ML file, S3 bucket is this. And files drop location is this and all this. So let's quickly change the Kishore, can you change the bucket name, please? Okay, yeah, that's it. And also, can you, okay, so that is there. So now what we are doing, the objective here is basically to so that's what basically what we are saying, like we have this S3 bucket. We have this S3 bucket from which we are reading data from. And then what we are doing, we have this, so let's put the code. So this is the path from which we'll be reading data, and this path is available in your S3 bucket as well. If you go to your S3 bucket, we have already uploaded these directories. This is the dataset, crime dataset we will be processing, and this is the drop location. Okay, these are the files currently available. We are processing data from this particular file. Okay, so we will be manually uploading files to this directory, and we will see it will be instantaneously getting processed. Okay, so now what we have done, you can see we have just added this data here. So this is the drop path. Okay, this is the file location from which we will be consuming data from. This is the schema. Then raw crime def is equal to spark.readstring. Okay, then option header true or false. Dot option max files per trigger to schema. This schema what you have created. Dot csv. So you see the syntax is pretty similar, isn't it? Earlier you are using spark.read.csv. Here you are using spark.readstream.csv, isn't it? Spark session.readstream.csv, and you will be reading data from this particular location. And you are saying header true or false, like the files what you are reading, does it has header, max files per trigger? These are a couple of additional options you are adding. Then you are basically checking if streaming or not, true or false. Print schema, Then basically here you are doing some processing. So that's streaming data frame dot select city, year, month, and value. This is the crime data set in London city. Okay. So 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 basically we can also include so we have included only these 4 columns: city, year, month, and value. Then with column renamed value to conviction. Okay, value to conviction, and uh, then basically on that particular database. So pretty much same syntax what you have seen earlier, isn't it? Data frame dot select dot with column rename dot with column, all these functions. Then how to, so this is what the processing, and then what you want to do with that data. I want to write it to a console. You want to write it to Cassandra database. Somebody else want to send an email. All these activities you can do. Then you are seeing crime df dot write string. There we are using write. Append mode is output mode is append. There you call normal mode, right? So data frame dot write dot mode dot format console dot option truncate false dot option num rows dot option num rows num rows, basically number of rows. These two are basically pretty much same like your show function. Show function truncate true or false and how many records you want to see. If this parameters talks about that, and then dot start. Okay, dot start dot await termination. So this kind of code will be running 24/7. It will not be stopping because the data is being generated at a continuous stream, and you have to process it at a regular interval, and you have to keep on processing, isn't it? That's the whole idea. So there basically there basically what you're doing. So let's try to execute the first program, and then you'll get a sense like how things are working in the backend. Okay, so it's working now. You can see like the control is waiting for you. Okay, just 1 second. This is running, and now what we'll be doing, we'll be going to the same location, drop location. We have 2 files, XAA, XAB. I'll be copying some more files into the same location, and let's see like how things happen. So we have this crime data set. I'll be setting in XAC, XAD, these 2 files I'm adding. I'm saying copy. Oh God. Okay, just you can see just why it is disabled. They're changing the interface. Recently they have changed this interface. Oh, what happened here? Okay. So that means 2 files has been added there. Let's see, you can see it has processed. Okay, now you can see batch 1. Earlier you saw batch 0 was there, so it processed data like that, and then once you added 2 more files, a new batch has been added. Okay, then you can add for the new files. Say I'm adding another file. Here you are manually doing, but you can see in the real time some systems are basically adding data to this directory and you are processing it. You copy the data, then you see instantaneously it processed, it became batch 2. Earlier it was batch 1, 0 and 1, now batch 2 got added. Like that, we have given max files trigger is basically, max files trigger we have given 2 files at a time. Let's see, like you can add multiple files, like say 3 files. 1, 2, 3. So again, 3 and 4, the two batches added. Because we have added 3 files, it will take 2 files at a time and then the third file again in another batch. Like that, you can process data, like you can imagine like new files are getting added to your system. Okay, new files are getting added to your system and you are processing it instantaneously, isn't it? So new files are getting added to your system and you are processing it instantaneously. It can be any example. So maybe basically at a regular interval, files are getting so you have so some production system, they have written some script that will basically keep on extracting data from that will keep on extracting data from some database, and then you are and they're creating CSV files and you have to process it and you have to process those files. Okay, so in that case, what happens? In that case, like their automated system, they have written a SQL script or shell script that will keep on extracting data from the data and they will upload the data, they'll upload some data into some location. And
your voice is breaking, Siddharth.
Is it?
Yeah.
Is it for everybody? Hello?
Yeah, it was breaking in between.
Yes, it's breaking, Siddharth.
Okay. Now it's good, right?
Yeah, better.
Yeah. So basically, files are getting added to the directory at a regular interval, and you are processing it instantaneously. Okay, so you can see some production databases. They are not giving you direct access. Rather, they are saying we have written a shell script or we have written a Python script which will read all this data at a daily at every few minutes or every 1 minute, and we will dump the data into S3 bucket. So you start processing data from that directory. You got my point, right? Because most of the time what will happen, so nobody will give you production database access because these are serving real-time customers, and if your big data jobs will be start fetching data from that systems, so that will become slow because Spark is running on multiple computers and they will be parallelly reading data from that database. So the database will be becoming very slow. Okay, in that case, what happens? We have to make sure like how to so the production team, they will be giving you the production team, they will give you a they will not give you the production database access. Rather, they will say you they will tell you like let's use this so we'll be creating an automation script for you which will take all these new records inserted to our database and we'll create a CSV file and we'll upload it to S3 and you try to process from that location. Okay, that can be one ideal scenario this use case fits in, isn't it? So that is one thing, and this is one type of example you saw, like this is append mode. Append mode means you have to only work on the new data. Getting my point? You only
And where are we specifying? Can you please show 2 files at a time and time-based triggering?
time-based triggers, there are other examples are also there. We'll see.
Okay.
Okay. So by default, I think it takes 5 seconds, but you can change it. Okay, you can change it to 1 minute, 2 minutes, like that. So what I'm saying, like here, so here basically we are basically processing it in append mode. Okay, you can mention that in append mode, so the data will be getting appended to that system. That means basically you are working on only the new data. Okay, so certain use cases, most of the use cases are working on new data only. All these browser cookies data and this database delta files, what you are reading, how to process that, those kind of examples are append mode. Okay, so you are working in the append mode, and the next thing is basically that is in append mode, and the next thing is basically what is the next thing is basically complete mode. Okay, complete mode is basically every time a new event is happening, you are processing the entire data. Getting my point? So append mode is most of the time we use append mode. Append mode is basically only working with the newly arrived data. But complete mode is basically every time a new event is happening, you are processing it in a complete mode. Okay, you are processing it in a complete mode, saying the examples can be, suppose you are monitoring till now what is the total number of transactions happened, total count of transactions happened, like that. You walk into say Flipkart office, you see there is a LED dashboard showing we have processed 1 million smartphone order last 1 month, or we have processed 100 million transaction orders last quarter, or like last year, like that, those kind of matrices. So that means every time a new event is happening, they're recalculating these matrices, isn't it? So how many total orders happened, how many total counts happened, total amount, total revenue they made. Okay, or in this kind of this kind of use cases, and also you can think of stock exchanges. In stock exchanges also, you can see every day they start the day, they have dashboards showing different dashboards showing different matrices. One dashboard is saying like maximum order processed is 20 lakhs rupees. Okay, or like today's top performing stock is say TCS. Today the least 5 generating stocks are basically this 4 or 5 companies, like that. So those kind of use cases are examples of complete mode. Okay, every time a new event is happening, you are processing the entire data. Okay, append mode is basically you are only processing the newly arrived data. Complete mode is basically you are processing the entire data. That means you have to do some aggregations. You can't just simply write the entire data in every 1 second. That's practically not possible, isn't it? If you are using complete mode, means it's mandatory that you have to apply some aggregations. Okay, like that. That is there. So let's see one example of complete mode. Okay, in the same like S3 bucket, when any new files getting added, so you have to process the entire folder. Okay. So same example, if you see. Complete mode, if you see, in the complete mode, we are doing the same thing. Spark session.readstream.option, header, max files per trigger true, and all this. Here, on this particular data frame, you are basically calling group by city count, order by descending of count. So you're counting the total number of crimes happened in each of these cities. Okay, this is the aggregations you are doing. That means anytime you are doing aggregations, it should be in the complete mode. Okay, write stream dot output mode is complete mode, format console, truncate false, numbers, and all these things you're doing. Ankun, are you following? I'm not saying anything.
Yeah, I'm following.
Time bound example, I think I didn't mention here. Okay, I'll show that in some. I think we have to just check what is the option for that. Yeah, so first time you can see the schema is printing, and then we can see the count of records. So count of crimes happened in each of these cities. So it's calculating that. It's taking a lot of time. Yeah. So you can see it's counting like top, in the top, that's Wandsworth. Wandsworth is having highest number of crimes, that is 91. Then Brent having 88, Barnett is having 86, like that. And the list is not that last record, because we are only showing 30 records. So, but if you show all these records, then it will maybe showing you all this list of them, list of cities along with the count of things. So you can say keep on executing, because we have given max files per trigger is 2, and we have almost kind of 5 files are there. So it should create 3 batches, right? Okay, batch 0, batch 1. So now we can see earlier some other city was there. Now Croydon is having the highest number of crimes. Last time you saw Wandsworth was having 91, and then Brent, then Barnett. But now Croydon becomes the top, 175 crimes. Wandsworth is having 169, like that. Barnett came to the third. Southwark is the fourth, 162. Then you can see the third batch also started. Same Croydon is basically maintaining the first position. Brent came from third position to second position, having 247 crimes. And then Wandsworth was having 3. Now I think there are more files are there. So I think this is the last batch. Croydon is having 342 crimes. Wandsworth is having 324. Enfield is having 318. Then Barnett came to the fourth position, 317, like that. All these things are there. Okay. Now you can keep on adding files just like you saw last time. You can also follow the same approach. Okay, you can follow the same approach to find out the total crimes happened. Okay, you can find out the total crimes happened in each of these cities separately. Okay, that is one use case. And the next thing we'll be trying is basically we'll set up Kafka. Okay, okay, I think I have another example there. So how to use Spark SQL here. So it's pretty straightforward. Same, just like you create a stream data frame, Spark session.read stream.format, CSV Parquet, whatever it is. And then basically once you create a data frame, you can create a temporary view, Spark session, say the data frame.create a replace temp view, crime data, and then you can execute SQL queries also. Okay, exact same thing, and the same example I'm trying here in Spark SQL also. Okay, these are there. And the next thing is basically what we can try is, so this job will be keep on running 24/7. Okay, that is there, because these are continuously running jobs. Okay, next thing is basically we'll set up Kafka. Okay, so I think this is your, can you log into the EC2 machine please, Kishore?
Siddharth.
Yeah, please.
Yeah, so the streaming is for here we are using as a batch processing, right? Not in a real time.
No, it's real time. Why are you feeling like it's batch based?
Because I think streaming also can be used as a batch based. So that's what I was thinking.
No, why are you getting confused? So batch based means once you run the application, your data, you have a fixed amount of data that you just read and did the processing and write the data to the destination. But here it's keep on processing. New files are getting added and you keep on processing. It's not stopping. It's running forever. A
Okay.
new file will be added to the source and you will be processing and you'll be writing data to the destination. And this process is indefinite. It will keep on running.
Okay.
we just logged into the EC2 machine, okay, what we have created. So now what we will be doing, we will be installing Kafka there. It's pretty straightforward. We have already the scripts available to, we have the script available to install Kafka.
So what is Kafka here, Siddharth? Is it we are having Spark streaming. So what is Kafka here? Is it a third party or?
So Kafka is basically, you can say it's again another streaming data source. Okay, so in a streaming application, there are three things. One is the source from which is generating continuous streams of data. Another is basically the processing, who is processing that data. And the third thing is basically the sink, where you are publishing your processed data. So we saw one example, you are reading data from some file system, say S3, where files are getting added at a regular interval, and you are processing it also instantaneously and storing it in the destination. Similarly, Kafka is one of the most common source of stream data. It's a distributed message broker. What is message broker? Message broker is basically a system that is used as a middle layer. For example, like you have, suppose you are implementing, you are basically running your own e-commerce business. Okay, you are basically selling some, what do you call, say some stone crabs. Okay, so you are basically procuring this stone statues and all, and you are selling it. Okay, so you have built your own website. Okay, initially there was less traffic, like daily 1 or 2 sale was happening. So your application was, the application what you have created, so it's pretty good. It's now working fine. So this is able to fulfill the customer's request. So with course of time, say at 10 years down the line, you are giving really nice products to the customers, and people are happy. People from different country putting orders to your website. But your website is, you have developed your own website in the past because you had less budget at that time to create this website. So you have designed the system in such a way that it can process maximum, say 5 orders at a 5 orders in an hour. Because it's a lengthy process. Yeah, this process is, so you have a capacity to process maximum 5 orders per hour. But now you are getting sometimes 10 orders, 20 orders, 5 orders, 1 order, like that. So how you'll be handling this? If you just allow all these requests to enter into your system may malfunction. It may give wrong output. One person is trying to purchase one product, but so you're shipping it a different product, or orders are failing most of the time. So customer will have a very bad experience. Rather, what you did, so instead of directly stopping your website and then spending another 6 months to create a website, sorry. So instead, what you did, you just implemented. So you don't want to stop your business, so you introduced a middle layer. Middle layer means you just added a message queue in between. Okay, once a customer put a request, it will not immediately get fulfilled. It will not immediately allow to your server. Rather, it will be pushed to a message queue. Message queue is a basically concept where you can, queue is basically a first in first out data structure. Like you have to keep on pushing messages. The first message got pushed into the queue will be the first message which will be processed. So you added a message queue in between. And that message queue will keep on processing. So all these requests will be entered into that. Okay. So once again, that message queue is now basically handling all these requests, and you have configured in such a way that it can keep, it can basically take any number of messages been added to that, but it will dispatch only 5 messages at a time in an hour. Okay, that means you have now avoided that. Lag. Okay, earlier you had a lag of limitation that you can process 5 requests at a time. If more than that number of requests are coming, your system was malfunctioning or you are getting a different behavior. Now you introduced a message queue in between. So which has been configured in such a way that any number of customers coming to you, they are putting orders. All these orders are recorded, but it gets processed 5 at a time in an hour. Okay, so that is basically the significance of message queue. So this is basically pretty straightforward, like what we were using in the software engineering since multiple decades. But how Kafka is different? How Kafka is different? So earlier, all these message queues were basically standalone systems. That means you have configured your message queue, which is standalone, like which is hosted over a single machine, and that single machine is having whatever capacity it can process that much of a request. But now this message queue is having it's a really good architecture. It works in a publisher subscriber model. Like producers can publish messages to a queue, and consumers can consume it. So the same thing gets a lot of traction. So in many different applications, people started using it, and some use cases where the number of requests are coming is way more. Okay, it's not like traditional banking application or e-commerce, traditional banking application or like that. Rather, if you just consider the example of what you call this e-commerce companies or social media networks, so they have millions and billions of requests coming every second. Okay, in that case, what happens? This standalone message queue will not be sufficient to handle this much of request. So there we require a distributed message queue. Okay, distributed message queue means your message queue is not hosted on a single machine. Rather, you can set up a cluster of multiple computers. Okay, you can set up a cluster of multiple computers, and that cluster of multiple computers will collectively handle your request. Okay, they will collectively handle your request. So that is basically distributed message queue. Kafka is one of the very widely used message queue. Okay, Kafka is used here. So we are installing Kafka as a standalone Kafka, but Kafka has many managed Kafka systems. Just like you saw, RDBMS like MySQL is a database, but here we used a managed MySQL. Okay, we just use AWS RDS to host a MySQL database. Since you don't have to spend more time on the server installation DevOps part, you simply delegated the task to AWS. Similarly, Kafka is also, it's a very widely used, very popular message queue, distributed message queue. So many prominent companies, they are providing Kafka as a service. Okay, and the best one is the Confluent Kafka. Confluent is the team. Kafka is the product of LinkedIn. So a group of people developed this thing, and a group of people developed that in LinkedIn, and later they just open sourced it. And those group of people come outside of LinkedIn, and they started on a company called Confluent. So Confluent Kafka is one of the best Kafka queue provider. And AWS is also having its own service, AWS MKS, okay, managed Kafka service. They are also providing similar service, and AWS is having its own publisher subscriber service called Kinesis. AWS is also having another system called Kinesis. Azure is having Event Hub. Google Cloud is having PubSub. These are all working in the same model, publisher subscriber model. Okay, like that. So that is one thing. And along with that, so that is basically the high level overview of Kafka. Okay, so let's do the installation of Kafka. So Rama, does it make sense? Like you got some understanding what is Kafka and all?
Yeah.
Actually, it's vast. I'm just covering only introductory part because it has a lot of things actually. So I'm streaming part. I'm just covering the basic because whatever we have discussed, the content is really huge. Like once you start jumping to interviews, if you just mention hundreds of things, it will be really tricky. So just with basic knowledge of streaming part is also sufficient. You can say you have experience in Spark batch-based processing. Don't say anything, like they will be directly starting with batch-based processing only. But if they will ask you like how comfortable you are into streaming and all, You can say, yeah, I have some POC level of knowledge, like I've created some POCs on that, maybe not production ready application. So we are installing Kafka.
So here it is a single node cluster, right?
Correct, it's a single node cluster.
If it is a multi-node cluster, do we have any feature to directly, like we did it in EMR cluster, the same way, do we have any facility to
No,
create
actually it
Kafka
doesn't run
cluster?
on Yarn cluster, it runs on Zookeeper. It's again another coordination service. So that's why like Kafka it's not tightly coupled with Yarn. It works on Zookeeper. Zookeeper is a message coordination, server coordination service. Zookeeper is used here.
Okay.
What is Zookeeper? What you tell?
Yeah, Zookeeper. Okay, so you made that changes. Just follow the steps. I mentioned it clearly. Then first you have to start the Zookeeper service. Hit enter again. First you started Zookeeper service, then you can start the Kafka server. Then we can create a topic called test topic. Topic created. We copy the DNS name. So it's showing. So the second this command is basically list the number of topics available. So it's printing one topic because we created one topic only there. Okay, so that is there, and post that what we are doing. Everybody just give it a shot. Okay, just install it so that you feel confident. Now I'm just opening a producer. It's a console-based producer. Okay, I'm here. I'll be sending messages, and this will be executed there. Okay, so for that I have to do a couple of changes. And that changes is basically on the EMR cluster side. I'm stopping this. vi dot secrets. Oh, why these are coming here? You have to just add another configuration here called Kafka. Oh no. The rest of the things you can delete because we need only these two. Okay. Okay. Now basically what we can do, we can go there. Let's go to the first example, that is append mode demo. I'll just explain this, but let me just quickly see whether the setup is correct or not. What it is saying, dot option, append mode demo, line number, server. So I think I did a mistake. Server spelling is incorrect, I think. Oh. Okay, cool, it's working. We can send some messages. This is Kishore Systems. Hello world. This is Kishore. This is my first streaming example. Like that, you just push this kind of messages to this topic, test topic. Okay, and so you can see these are getting processed here. First time initially it was no record, then you mentioned hello world. This is Kishore. This is my first Spark program. Like that, it's keep on processing that. Okay. This is basically in the append mode. Let's see the syntax wise. Syntax wise, again, there is no much difference. So Spark session.readstream.format. If you by-hearted that syntax, you don't have to remember anything. There you are mentioning Spark session.read.format, CSV, parquet.json, load. Here you are basically, instead of read, you are calling readstream, format Kafka, Kafka bootstrap server you are mentioning. Okay, you are giving the server IP address, colon 9092. Okay, you're basically giving 9092 and then subscribe. The topic name you are providing, test, then load. So it creates a data frame, streaming data frame. Then you are saying streaming data frame, select expression. So all these messages come as key value pairs. So you are using this one called cast value as string, then write string, output mode append, format console, checkpointing location. This is very, very important. Checkpointing location, what's the significance? Basically to handle the failover mechanism. So your stream application is running. Okay, you can see in the console it's running 24/7 up and running. Suppose all of a sudden for a given few minutes, like millions of requests came in and your cluster got crashed or your application got crashed. So that means the second time when you read the data, so how you'll be getting to know? Will you process from the beginning? So your application is running since last 1 year. So processing the entire records for that 1 year will be literally not possible. So you should only process the data where you have left. Okay, so those parts for that purpose, like for failover mechanism, we use checkpoint location. So every time you read a message or event basically generated from Kafka, it is associated with the offset number, okay, or integer offset number. So that offset basically stored there in the checkpoint location. If your application fails, it will basically start reading data from that particular location. For example, say I just Control C, I stop this application. Now I'm again saying, I'm coming to this topic. I'm saying Siddharth, this is my second Spark program, like that. Okay, so now let me re-execute this. Last time what happened, I Control C, but just feel like something went wrong and your application got crashed. Okay, it stopped. Now you are processing and you are re-executing the job. You see, it's not reading from the first message. Okay, so your first message was hello world, then this is Kishore, then this is my streaming application. After executing these 3 records, your application crashed. Okay, so we are very poor engineers. We have written a code after processing only 3 messages, it got crashed. But anyway, we are smart enough. We just implemented a failover mechanism. Even though it got failed, second time when I relaunched the application, it got to know I have processed the first 3 records. I have to start from the 4th one. So you saw from the 4th one, it started processing. Okay, this is what is called as, this is how you can consume data from Kafka. And complete mode example, I think I have implemented a word count example, your favorite one. So same thing. So every time you're reading complete mode means you have to read from the beginning. You can see from the earliest. Okay, and here we are reading the value part, then split it through space, then explode, then go by value, aggregation, counter values. Okay, so this is the streaming word count example. Okay. So you can see all these things are coming here. All these word count. Let me intentionally add hello count, hello world multiple times. Hello world. Again. Hello world. Every time you push a message, this recomputation will happen. Okay, you can see earlier hello one, world one. Now hello one because I've used small h, but world becomes twice. Right? World became twice. Now again world became thrice. Like that. Like that also you can walk. This is how you can use. So if in case you are showing streaming applications in your resume, don't say that you install Kafka by your own, because we don't do that. We use any managed Kafka cluster, because you see there are multiple services are running. You have to manage all this. So you say we are using Confluent Kafka or AWS MSK, so MKS, managed Kafka service. Because nobody will trust if you say like I am installing, DevOps people install Kafka by their own and all. It's hard to believe. Nobody believes that. Yeah, because it's a huge task. Okay, you have to manage the partitions, you have to manage the nodes, all these things. Got it? Any queries till now?
So Siddharth here, producer was the console application and consumer was our Spark application, is it?
Exactly. We are working in the downstream part. We are processing data from a Kafka topic. We are not producing. There can be some applications where you are producing data, but very less use cases like that. Because we are into data engineering, so we have to process the data. Source is some production systems are generating data. So we are processing, we are consuming the data here.
So that whatever you wrote in the console, that was going to Kafka topic, right?
Producer part, you saw two terminal. One is the EC2 terminal. That's the producer where we are manually producing data. And in the EMR cluster, there we are consuming the data. Here, consumption side, we didn't do anything interesting. We are processing and writing the data to console. But you can think in real-time use cases, if it's a fraud detection system, if you see a fraudulent transaction happened, you have written the business logic in the code, then you send an email trigger. Or if you are working in a Lambda architecture, you are reading data and processing it and then storing it in S3 as well as you are writing it to some Cassandra. Those kind of use cases also you can implement. You can write this data to Cassandra also. Different type of use cases you can execute.
So Kafka is a middleware here, right?
Exactly. Ankon, any queries?
We install Kafka here na in EC2. Okay.
Correct. Yeah.
First we give the input from EC2 to the Kafka
Exactly. On the EC2 we have installed Kafka, and in the same EC2 only we have started the producer thing. So producer is also available as part of the Kafka installation. So then we executed the producer command so that it created the producer console, and there we are sending messages by typing. We're hard coding the messages there and sending it.
These hard coding, these messages, are they in between Kafka or outside of Kafka to in Kafka?
You can say outside to Kafka. Here producer is a console based producer, but in real time there can be other applications which are writing to Kafka. Yeah, which are writing data to Kafka.
Now our hard code exam strings are go from EC2 to go to the Kafka. In between Kafka, we run the code and get the result.
EC2 to Kafka, then from Spark we are reading data from Kafka.
Okay.
Getting my point. One system is publishing messages. Just think like it's a publisher subscriber model. Some systems are publishing messages to Kafka. Some services are consuming data from Kafka. Okay. So in EC2, we have created a mock console-based producer, and there we are hard coding the messages. That means we are publishing the messages manually, and then we have written the code in structured streaming in Spark, which consumes the data from Kafka topic or Kafka queue. Okay. Once we install Kafka, Kafka is a message queue service, but it's not necessary that you have to only host a single single topic there. On a complete installation, you can have multiple topics also. In a given Kafka message queue, in a given Kafka server, you can have multiple topics. Okay, you can have multiple topics, and multiple topics are published with data, and different applications are publishing data to different topics. Different consumers are reading data from different topics. Topics is a way to basically segregate the messages. Okay, different applications are publishing data to your Kafka server. You shouldn't publish all these messages to one topic, so your data will be corrupted. You will not be able to process it properly. Getting my point? Suppose sales data also you are pushing, customers data also you are pushing, user activity data also you are pushing to Kafka. Then there should be different queues. Different queues should be there to take these records. So that's why we create different topics there. Okay, so each topic corresponding to one data set, another topic for another data set. So similarly, consumption side also, so different consumer can consume data from different topics. Got it?
Yes.
So Siddharth, in those topics, sometimes they send that JSON messages also, right? So how to process
Not
that?
sometime, you'll always get JSON or Avro.
Okay.
In real time, from Kafka topic, you will always get JSON data or Avro data, which is very nested, huge data. You have to read each of these record, you have to parse it, and you have to process it, and all this thing you have to do.
Okay.
Any other queries on this? Vinay?
No, Siddharth.
So we can have like REST API services also pushing data, right?
Yeah, any system can publish data. So if you'll ever get a chance to work on different streaming applications, there you will see the message provider or publishers can be many. Okay, suppose you are a e-commerce portal and you are doing your marketing on different social media networks. Okay, you spend daily say $1,000 on Facebook, $1,000 on YouTube, $1,000 on LinkedIn. So different customer base are coming from different website, different messages, different social media networks. Suppose I am using Twitter a lot. So for me, when I saw their ad on Twitter, I clicked that. Okay, so basically, business is investing in different amount, different uh, basically marketing budget on different social media networks. They want to see like how the referral programs work, like how this referral program work. Like basically, uh, so basically, uh, my point is basically how many traffic coming from which sources. So from Twitter at a daily basis, 5,000 customers are coming from LinkedIn. Say 100 customers are coming from say Twitter. 10,000 customers are coming. So in that case, we will see like they will be creating some system, and that will always keep pushing messages. If somebody clicked a link there in Twitter, so a message will be added to Kafka. And similarly, a person who clicked a referral link on Facebook, a message triggered into a Kafka topic, and then you are processing it in the downstream using structure stream. So to track like how your marketing budget, to that will basically people use those kind of setups to properly identify how to distribute your marketing budget on different channels. You are getting maximum traffic from Facebook. Let's spend more budget on Facebook, like that. Getting my point?
Okay, but why why is Spark here we call as structured streaming? Like any reason saying structured streaming?
Why Spark is called Spark? That also I don't know. Okay, anyway, like structure streaming means there is no such thing, but we can interpret like that way. Like earlier, like the earlier version of Spark streaming was called DStream or discretized stream. So that is basically working on RDD syntax. Okay, you have to read the data as RDDs and then process it. But here you are reading the data as data frames. You are reading the streaming source as data frames and then processing. That's why might be they have called it as structured streaming, because data frame is working on structured data and you are reading the Kafka topic data as data frames, which is structured. Maybe that's why it's called structured streaming. Let's just understand, but there is no such prescribed rule. So it's just a module in Spark.
So if you're reading some data like Twitter and all to process, which layer will be responsible for structuring it to Spark? Is it like the producer would have, we as a producer, API will be structuring, but where will the structuring happen of the data? Because Twitter and all is unstructured, right?
Next, when you are reading Twitter feeds, each Twitter feed is having multiple fields. That timestamp which the feed generated. Okay, who was the person? How many people are tagged? Okay, so what's the So there are many different attributes of a message of a Twitter feed. So while setting up this process, like it's not straightforward. You can't directly process it using Spark. So you have to first bring those Twitter feeds to a Kafka topic and then process it. So sourcing that data means reading data from from Twitter and publishing it to Kafka. There basically you have to do the structuring. You have to read the feeds and you have to mention which are the attributes you are looking for. Basis that you have to create the message and publish it to Kafka. Then in the downstream, we are consuming the data from topic.
So your producer API development will be done where?
Producer API is basically that one. Like you'll be using Python TweePy library that will be consuming data from a Twitter page, and that will be writing data to topic. So there the API part is involved. There you have to use all these techniques to make the data sourcing. Read data from Twitter page to Kafka topic. There you have to use all these APIs. Okay, if you're in the backend, they're using this RESTful APIs only. All these what do you call reviews, all these social media feeds. These are all working in a API based. Every time something happens, it just you have to subscribe the service, subscribe the API, and you will keep on getting those messages.
Okay, in this example you showed like where on the console you wrote like multi-line text, right? So how it's knowing like schema, like where are we bounding the schema here?
It's new line character. Every time you hit enter, that's a new record there.
Okay, but we can't pass any multi-line here.
Yeah, you can pass multi-line. Line means class name. You can't pass multiple lines as one message. Each line is a new message here.
Okay, so here we also have to be good in writing the topics from the producer to Kafka also, right?
Right.
Okay, like typically like what do we deal with? Like someone is doing that and we only take care of the distributed processing in Spark?
Yeah, we are mostly working always on the processing part. You don't have to worry about how is processing because that's part of the software engineering. People who are developing the front end, they're structuring the data. When an event is happening, what are the data to be published to the topic? There only they are creating that JSON tree. That JSON tree is having all these attributes required. Then they're publishing those JSON documents to your topic. Then in the downstream, we are basically getting all the JSON data to process.
Okay, by default, you said Kafka prefers Avro or JSON, is it?
They don't prefer anything. It's basically you have to specify on which format. You are sending messages. You can send text message, JSON message, Avro messages like that. Getting point.
Okay, and each have their connectors.
Okay. Any other queries? Okay, then that's all from my side for today. Okay, so we'll again connect next. Okay, just practice this program. Okay, don't keep it. At least you should one time you should do all this. Okay, so that later you will be confident. So don't miss it.
So we'll be continuing with Kafka only. So that next class also. I mean
No,
structured
streaming is
streaming.
this much of streaming only.
Oh, we won't be any like window, all that watermark you mentioned. We won't be doing those, is it?
No, those things we are not going to.
Watermarking.
These are basically will be very hi-fi concepts. I don't want to confuse people because the objective is to basically go through the like streaming part. I avoid people to mention in your resume. Even if you're mentioning, just mention only introductory level. Okay, because a lot of things will coming. Like some people will get into Kafka message groups, the consumer group, consumer side partitioning, and all this. And that's again whole bunch of story. So cracking interviews like Spark batch based is sufficient. Okay, you can go ahead with that part. But if you want, I can share some examples. But the idea is basically Spark thing, sorry, streaming thing, you should mention this much. Okay, not a lot of things.
Okay. So
Right,
next class, what we'll be covering?
Next class for you, your project part will be continuing.
Okay. All that the AWS Glue and step
Yeah, and
functions, is it?
those are there. Those are I'll be taking merge sessions. Okay, and when I'll be covering that, I will ask you to join this group combinedly. So Delta Lake will be one session. AWS Glue will be another session.
Okay. Okay.
Okay, thanks everybody then.
Yeah, thank you.